Section 8.1, Solving Linear Equations, x plus b equals c and ax equals c. Our objectives for this lesson are to determine and define the term linear equation, to solve the equations of the form x plus b equals c, and to solve equations of the form ax equals c. So let's start our lesson with a little bit of terminology. First of all, let's define what we mean by the term linear equation. So we're going to let the letters of the variables a, b, and c stand for constants or numbers, and a can't be 0. Then we say that a linear equation in x is an equation that can be written in the form of ax plus b equals c. A linear equation in x is also called a first degree equation in x because our variable is written with an exponent of 1. So x means the same thing as x to the first, and since our exponent is 1, then we call this a first degree equation. To solve equations of the form x plus b equals c, we're going to use what's known as the addition property or principle of equality. And what it says is that if some algebraic expression is added to both sides of an equation, the new equation has the same solution as the original. So again, if a, b, and c, capital A, B, and c, are algebraic expressions, then if we have the equation a equals b, then the equation a plus c equals b plus c has to have the same solutions. Now we're going to look at some general guidelines for how to solve equations when they're in the form of x plus b equals c. So the first thing you want to do is see if you can combine any like terms on each side of the equation. Then we're going to use our addition principle of equality to add the opposite of whatever our constant b is to both sides. That's going to eliminate the b from the side with x and get our x by itself, and we want it to have a coefficient of 1. Then we're going to check our answers by substituting into the variable in the original equation and make sure that our equation is true, because that's our job, is to figure out what value could we substitute in for x that would make our equation true. So let's look at our first example. We have x minus 3 equals 7. So to get the x by itself, because we're trying to get x by itself to solve for x, what I'm going to do is I'm going to get rid of this minus 3. The addition principle of equality says that if I want to eliminate a minus 3, what I will do is I will add 3 to both sides. Now, some books and programs will write this horizontally rather than vertically, and I'll show you what that looks like in just a second. I like to line them up vertically so I can see that a negative 3 and a positive 3 when added together is going to give you 0. So this would just be x equals 10. And now if I check it, I would go back to my original equation and I would let x be 10. And I get 7 equals 7, which is true. So I know I have the correct solution. Now, we'll not spend time checking all of our solutions on the video, but you should take time to check your solutions to make sure that you are correct. Now let's look at our next equation. Negative 11 equals y plus 5. One thing that may help you with this is to rearrange the equation so that you have your variable first, if that's possible. So what I'm going to do is I'm just going to rewrite this so that y plus 5 equals negative 11. Then I want to eliminate this plus 5. Well, by our addition principle, I can get rid of a positive 5 by subtracting 5 or adding negative 5. And that would give me y equals negative 11 plus negative 5 would be negative 16. Now, I mentioned on the last example that sometimes you'll see this written horizontally. So instead of writing it like I do, they would start the problem, looks like this, and then they would do y plus 5 minus 5 equals negative 11 minus 5. And then your positive 5 and negative 5 would cancel, and that would still give you y equals negative 16. It's just my preference is to write it vertically so I can line them up like an addition problem would have normally looked when you were in maybe elementary school, and then I can see how things are going to cancel out. In our next example, we've got negative 4.1 plus x equals 0. I could rewrite that equation as x plus negative 4.1 equals 0, or x minus 4.1 equals 0. And now to get rid of the minus 4.1, I would add 4.1 and get x equals, those will cancel, and give me 4.1. In the next problem, it's a little more difficult because we have fractions, but what we're going to do is we're just going to add 2/5 to both sides because we've got x minus 2/5, so those will cancel and give me x equals, and then I need to add 3/10 plus 2/5, which you can either do with a calculator or you can change 2/5 over to tenths so that we have common denominators by multiplying the top and the bottom by 2. And now I have that 3/10 plus 4/10 would be 7/10. So my final answer would be x equals 7/10. And again, you should take time to check these by substituting in 7/10 into our original equation and showing that that answer is true or does make your equation true. Now let's look at the next equation. In this problem, we actually have some simplifying of like terms that we can do first. On our right-hand side, we have 3 plus 8, which we could simplify to 11. And on our left-hand side, we have 3z minus 2z, but we understand that to be 1z, or just z, plus 2. Because we can't combine a z and a 2, they're not like terms. So now I can subtract 2 from both sides and get that z equals 9. Now let's look at how to solve equations if they're of the form ax equals c. Well, in those types of problems, instead of the addition principle of equality, we're going to use what's known as the multiplication or division principle of equality. So what it says is if both sides of an equation are multiplied or divided by the same non-zero constant, then the new equation has the same solution as the original equation. So again, if this is my algebraic expression, if I multiply a and b both by some constant c, then we have the same solution. Similarly, if I started with a equals b, and I divided both of those sides by c, where c can't be 0, then we have the same solutions for those equivalent equations also. So if we're solving equations of the form ax equals c, our procedure is very similar to what we did before, except for step number 2. Instead of the addition principle of equality, we're going to use the multiplication or division principle of equality to get rid of or to eliminate our variable that's being multiplied or divided with our x. Since it's not being added or subtracted, and we're multiplying or dividing, then we're going to use the opposite property to eliminate that from our x. So again, we want our coefficient of our variable to be a positive 1. So in our first example, we have 5x equals 20, and I'm actually going to solve this 2 different ways. Now, because I have 5x equals 20, you need to remember that 5x means 5 times x. And I'm trying to get the x by itself, so what I could do is divide both sides by 5. Because 5 divided by 5 here would give me 1x, or just x. And 20 divided by 5 would be 4. So we get x equals 4. The other way that I could do this is rather than divide by 5, I could multiply by 1/5. And I'm multiplying both sides by the same constant. 1/5 times 5 is 1. So again, I get 1x. And 20 times a fifth would be 4. So we get x equals 4. There are times when you solve problems where you're going to want to do it by this first method where you'll divide both sides. And there's other times that it's going to be easier if you'll do it by multiplying by the reciprocal on each side. In our next example, we've got some like terms that we can combine. We can take 1.1x and add 0.2x and get 1.3x equals, and then I can take 12.2 minus 3.1 and subtract those, and I'm going to get 9.1. Then I want to divide both sides by 1.3. And now you'll take your calculator and divide, and you're going to get that x equals 7. In this next example, you're going to notice that you have negative x equals 4, but negative x is the same thing as negative 1 times x equals 4. So if I want to get that x by itself, I would divide by negative 1. And now negative 1 divided by negative 1 is positive 1. So 1x would equal 4 divided by negative 1 would be negative 4. Now let's take a moment and look at an application to solving equations. So Mark has a coupon for $50 off of a Blu-ray player that he just purchased. With the coupon, his purchase price was $165.50. So we want to solve this equation. Y minus 50 equals $165.50 to determine what his original price would have been for the Blu-ray player without the coupon. So if I have y minus 50 by the addition principle, I can add 50 to both sides. Let's put that zeros there to line those up. And now 165.50 plus 50 would be $215.50. So if he had not had the coupon, that would have been his purchase price for the item. We're now to the part of the video where you need to work on some practice problems. So what I want you to do is pause the video, work these 9 problems, and then once you're finished, restart the video and check your answers with the solutions that I'll provide. Now that you've had time to work through the practice problems, here are the solutions, so make sure that you check your answers, and any problems that you did not get the correct answer for, make sure you mark them, and that way we can discuss them the next time we're in class.